You're listening to leadai.dev, your daily updates on AI development. Today's topic is Cursor Composer gets real-time RL. Code Generation Breakthrough 2024. Here's a quick overview. Cursor's new real-time reinforcement learning system revolutionizes code generation by adapting to developer preferences through continuous feedback loops. Now, let's ask our analyst about these developments. What's new? Cursor Composer's real-time reinforcement learning system?
Cursor has deployed a groundbreaking real-time reinforcement learning system for its Composer feature, fundamentally changing how AI-powered code generation adapts to developer preferences. This implementation marks the first production-ready RL system in mainstream code editors, processing developer feedback within milliseconds to adjust code suggestions dynamically. The system operates continuously during coding sessions, learning from accept/reject decisions, code modifications, and contextual patterns to refine its output quality in real time. The technical architecture leverages a lightweight policy gradient method that runs locally within the Cursor environment, ensuring zero latency impact on code generation speed. The RL agent maintains separate reward models for different programming languages, frameworks, and coding styles, with each model updating based on implicit feedback signals like cursor movements, selection patterns, and modification frequency. The system incorporates a multi-armed bandit approach for exploration-exploitation balance, ensuring it continues discovering better solutions while maintaining high-quality suggestions. Previous versions of Cursor Composer relied on static pre-trained models that couldn't adapt to individual developer preferences or project-specific patterns. The new RL system represents a 340% improvement in suggestion acceptance rates during internal testing, with particularly strong performance gains in complex refactoring tasks and API integration scenarios. Unlike traditional fine-tuning approaches that require offline training cycles, this real-time system adjusts its behavior within the same coding session where feedback is provided. Real-time policy updates with sub-100 milliseconds latency for immediate adaptation to developer feedback language-specific reward models supporting Python, JavaScript, TypeScript, Go, Rust, and 15 plus additional languages of multidimensional feedback processing, including keystroke patterns, selection behavior, and code modification frequency, local execution architecture, ensuring zero data transmission for a privacy-sensitive codebase's contextual memory system, maintaining preferences across 10,000 plus code completion sessions per project.
Thank you for that analysis. Let's move on. Who benefits from Cursor's real-time RL code generation?
Senior developers working on complex, multi-layered applications will see the most immediate benefits from Cursor's real-time RL system. Teams maintaining large code bases with established patterns and conventions experience significant productivity gains as the system learns project-specific architectural decisions, naming conventions, and implementation preferences. Full-stack developers juggling multiple programming languages within single projects particularly benefit from the language-specific adaptation capabilities, with the system maintaining separate behavioral models for front-end JavaScript and back-end Python code within the same session. Engineering teams with strict code review processes and established style guides find substantial value in the system's ability to learn from rejected suggestions and approval patterns. DevOps engineers working with infrastructure as code tools like Terraform and Kubernetes configurations see improved suggestion relevance as the system adapts to deployment patterns and resource naming conventions. Startup teams with rapidly evolving codebases benefit from the system's ability to adjust to changing architectural decisions without requiring manual configuration updates. Developers working primarily on simple scripts, one-off projects, or those who prefer minimal AI assistance should consider waiting for broader ecosystem integration. The RL system requires sustained interaction patterns to reach optimal performance, making it less suitable for occasional users or those working on projects with fewer than 100 lines of code. Teams with extremely restrictive security policies may need to evaluate the local processing capabilities against their specific compliance requirements. Full-stack development teams managing 5+ programming languages simultaneously, senior engineers maintaining legacy code bases with complex architectural patterns, DevOps teams working with infrastructure automation and configuration management, startups with rapidly evolving technical architectures requiring adaptive tooling.
Great insight. Really helpful context. How to get started. Implementing real-time RL in Cursor Composer?
Enable the real-time RL system through Cursor Settings panel under the Composer section, where the adaptive learning toggle activates the reinforcement learning capabilities. Ensure your Cursor installation is version 0.42 or higher, as earlier versions lack the necessary RL infrastructure. The system requires approximately 2 GB of available RAM for optimal performance and local model storage, with an additional 500 MB per active programming language model. Configure language-specific preferences by accessing the RL Preferences submenu and selecting primary languages for your project. The system automatically detects file types and activates corresponding models, but manual prioritization improves initial performance. Set feedback sensitivity levels between conservative slower adaptation, higher stability, and aggressive rapid learning, more experimental suggestions. Most developers achieve optimal results with balanced settings during the first week of usage. Verify system activation by observing the small RL indicator in the composer status bar, which displays learning progress through color-coded feedback signals. Green indicates active learning from positive feedback. Yellow shows exploration phases, and blue represents stable performance states. Monitor suggestion quality improvements through the built-in analytics dashboard accessible via C, M, D/Control plus Shift plus L, which displays acceptance rates, learning velocity, and model confidence scores across different code contexts. Navigate to Settings, Composer, Adaptive Learning, and enable Real-Time RL with balanced sensitivity. Allocate minimum 2.5 GB RAM for optimal multi-language model performance. Configure primary languages in RL preferences for faster initial adaptation. Monitor learning progress through status bar indicators and analytics dashboard. Allow 50100 code completions for initial model calibration before evaluating performance.
That's a very interesting point. Tell us about competitive context. How real-time RL changes code generation landscape.
GitHub Copilot and Amazon Code Whisperer rely on static transformer models that cannot adapt to individual developer preferences or project-specific patterns during runtime. While these tools excel at general code completion tasks, they lack the dynamic learning capabilities that allow Cursor's system to improve suggestion relevance based on real-time feedback. Tab9's personalization features require explicit configuration and offline training cycles, making adaptation slower and less responsive than Cursor's continuous learning approach. JetBrains AI Assistant focuses on IDE integration but doesn't incorporate reinforcement learning for adaptive behavior. Cursor's real-time RL system creates distinct advantages in code quality consistency and developer workflow integration. The system's ability to learn from implicit feedback signals like cursor positioning and selection patterns provides more nuanced adaptation than explicit rating systems used by competitors. The local processing architecture ensures faster response times compared to cloud-based alternatives while maintaining privacy for sensitive code bases. Multi-language context awareness within single projects gives Cursor significant advantages for full-stack development scenarios where other tools treat each language independently. The system currently lacks the extensive pre-training data that powers GitHub Copilot's broad knowledge base, potentially resulting in lower performance on uncommon programming languages or niche frameworks. Integration with version control systems remains limited compared to GitHub's native Copilot integration. The RL system requires sustained usage patterns to reach optimal performance, making it less immediately effective than pre-trained alternatives for new users or infrequent coding sessions. Real-time adaptation via static models used by GitHub Copilot and Code Whisperer local processing ensures faster response times and enhanced privacy protection. Multi-language context awareness surpasses single language optimization approaches. Implicit feedback learning provides more nuanced adaptation than explicit rating systems.
Good analysis. Let's continue. What's next? Future implications of real-time RL and code generation?
Cursor's roadmap includes expanding the RL system to incorporate team-level learning, where multiple developers' feedback patterns contribute to shared model improvements while maintaining individual preference isolation. Planned integrations with popular frameworks like React, Django, and Spring Boot will enable framework-specific adaptation patterns, learning from component usage patterns and architectural decisions. The development team is exploring federated learning approaches that could allow anonymous contribution to global model improvements while preserving local customization and privacy requirements. Integration partnerships with major cloud platforms and CI/CD systems are in development, enabling the RL system to learn from deployment success rates and production performance metrics. This expanded feedback loop could incorporate code review outcomes, bug reports, and performance monitoring data to refine suggestion quality beyond immediate developer preferences. A PI access for the RL system is planned for Q2 2024, allowing custom integrations with existing development workflows and toolchains. The success of Cursor's real-time RL implementation will likely accelerate similar developments across the code generation landscape, with major competitors expected to develop adaptive learning capabilities within 12 to 18 months. This technological shift toward personalized AI development tools represents a fundamental evolution from one size fits all models toward highly customized development assistance. The implications extend beyond code generation to potential applications in debugging, testing, and architectural decision making within integrated development environments. Team level learning capabilities planned for Q1 2024 with privacy preserving collaboration framework specific adaptation models for React, Django, Spring Boot launching Q2 2024, CI/CD integration for deployment success feedback loops in development phase, public API access for custom workflow integrations scheduled for mid 2024 release.
Great analysis. So, what are the key takeaways from all of this?
Enable real-time RL in cursor settings. Composer adaptive learning with balanced sensitivity for optimal initial performance. Allow 0 code completions during first week for system calibration before evaluating suggestion quality improvements. Monitor learning progress through status bar indicators and analytics dashboard to track adaptation effectiveness. Configure language-specific preferences for multi-language projects to maximize context-aware suggestions.
And what market signals should our listeners watch for?
Adaptive AI development tools. Cursor's real-time RL deployment signals a market shift toward personalized development assistance that adapts to individual coding patterns. This represents the first production-ready implementation of continuous learning in code generation, potentially forcing competitors to accelerate their own adaptive learning research. The success of this approach could establish adaptive AI as a standard requirement for next-generation development tools, fundamentally changing how developers interact with AI-powered coding assistants. Local processing preference. The emphasis on local RL processing reflects growing developer concerns about code privacy and data security in AI-powered tools. This architectural choice positions Cursor advantageously against cloud-dependent competitors, particularly for enterprise customers with strict data governance requirements. The local processing approach may become a competitive differentiator as privacy regulations and security concerns continue influencing enterprise technology adoption decisions. Real-time learning integration. Integration of real-time learning capabilities directly into development workflows represents a significant evolution from batch processing AI models. This approach enables immediate adaptation to changing project requirements and coding standards, providing competitive advantages in fast-paced development environments. The success of this integration model could influence broader adoption of real-time ML systems across various software development tools and platforms.
What should developers and operators do with this information?
Enable real-time RL immediately if working on projects with 500 plus lines of code and consistent development patterns. Wait 2 to 3 weeks before evaluating performance if switching between multiple small projects or working with unfamiliar languages. Upgrade to Cursor Pro subscription within 30 days if RL system shows 25% plus improvement in suggestion acceptance rates. Configure team level RL settings when onboarding 3 plus developers to maintain consistent coding standards and suggestion quality.
Thank you for listening to leadai.dev. Stay tuned for our next daily updates in this rapidly emerging market.